All right, so in this problem, we're going to apply virtual work to this cantilever structure. You can see it has a uniform load over about the first half, and then force applied at the freedom. We probably won't have time today to do the slope, so I'll just start it and get going on the displacement. Probably won't be able to finish it, but I'll hopefully get to at least through the moments, and then I'll fill it in and have it on paper for you to review. Because we've only got about 8-9 minutes for class, so I don't think I'll be able to finish it all. The first thing we're going to do is we're going to write the real moments for this structure. So I'm going to have to write a set of moments that are valid from 0 to 7, and a second set from 7 to 14. So imagining the structure cut here somewhere between 0 and 7, you want to work the left side or the right side. The right side is not so bad, a little clumsy, but you don't have to have any reactions. If you do the left side, the terms will be easier to deal with, but you'll have to find 2 reactions to get started. So let's think about that for a second. I think when you cut it between 7 and 14, it's clear. You want to probably work the right side. So just to show you that as a little difference, I'm going to cut it here, and I'm going to work the right side. So I'm not going to find any reactions. So let's write the real moment. So this will be valid from 0 to 7. So I'm going to cut it here and go right. So there's the load. So the distance from the left to the cut is x. And then I'm going to have a couple things I'm going to be curious about. Well, I know this particular part is 7. So what is this little piece here going to be? Well, I know from 0 to here is 7, and I'm going to subtract x, so it's going to be 7 minus x. And if you add it all up, what do you get? X plus 7 minus x is 7. Plus 7 is 14. So no matter what the value of x is, you'll always get 14. And then I'll have my force, equivalent force, is going to be what? It's going to be the area of this curve, which is the base, which is 7 minus x, times the height, which is 25. So this force will be 25 times 7 minus x. And the distance from the cut to the centroid will be this distance divided by 2. So with all that, I forgot something here on the end. Let's not forget that one. So if I sum moments about the cut, what do I have? Hang on, I forgot something important. The moment. So starting with the moment, is that going to be positive or negative with my sign convention? Negative. The concentrated equivalent force about the cut? Negative. So it'll be negative 25 times 7 minus x times the moment arm, which is 7 minus x over 2. And then 75 is also what kind of moment? Negative. And what is that moment arm?
7 plus 7 minus x.
Which is?
14 minus x.
So there's my moment expression. Doesn't look so good now, does it? So I'm not going to do that. I'm just going to say 25 divided by 2 times 7 minus x squared. That's negative. And then minus 75, 14 minus x. That is nasty. Now again, given some time, I'm sure you could all turn that into a nice little quadratic equation. We don't have that time right now, so I'm just going to leave it alone. Let's get the other one, though, that's from 7 to 14. We've talked about that. We're going to cut it and look at the right-hand side. So the distance to the cut is x, and the remaining little segment would be the length minus x, which is 14 minus x. And then the interior will have that bending moment. So again, I can sum moments about the cut, set it in equilibrium. So what kind of moment is that? Negative. And the 75 creates what kind of moment about the cut? Positive or negative? Negative. And has a moment arm of 14 minus x. Well, that's a little more manageable. That moment then will be negative 75, 14 minus x. I wrote kilonewton. This is kilonewton meters. So to even be able to write the statement now, all we've done is found two moment equations. What do we have to do next?
The virtual beam.
Yeah, the virtual beam. So let's see what the virtual beam would look like. So remember, the virtual beam has the same geometry. And it wants we won't do the slope, so let's do the displacement at C. Here's C, so what do I put at C? I'll put my virtual load, and I'll assume that it goes down. I think that's a reasonable assumption. I feel that this structure will probably deflect something like this. So I think it's going to go down. So hopefully I'll get a positive result. How many equations for a moment do I have to write here?
Two, just one.
Just one. So I'm going to cut it here. You want to work the left side or the right side?
The right side.
I think the right side is the winner. So I think what I'll do is I'll just cheat a little bit and say I'm cutting the structure here. There's my internal virtual moment at some distance x, and this would be 14 minus x. So looking at just this part of the beam and summing moments at the cut, what do I get? My internal moment is positive or negative? Negative. The moment produced by the virtual load about the cut is negative. And that'll be 1 times the distance. So the virtual moment everywhere is minus. Let's see, just leave it like that. I'll say minus 14 minus x. So there's all the pieces I need. So just enough time to build the virtual work expression. So obviously this virtual moment is good for the whole range. But this was only good for 0 to 7. So my displacement at C will now be divided into two segments. The first integral from 0 to 7 will be all of that. I guess you're going to make me write that again, aren't you? Minus 25 over 2 times 7 minus x squared minus 75, 14 minus x. So that's the real moment. The virtual moment is that. How do I represent that easily? I guess I could take that minus and put it out here in the and run it through all of these and make these all positive. You want to do that? Positive, positive, and this just becomes 14 minus x. This term now is all positive. Then the second one will be the integral from 7 to 14 of this, which is minus 75 times 14 minus x, times the virtual moment. That negative turns that one positive, and I get 14 minus x. So there's my virtual work expression, just in time because class is over. So what I'll do, believe it or not, is I'll go back to my office and I'll figure out what all that is, and I'll give you a numerical value and post it. But again, I'll draw a big red line here, because more than likely, if I ask you to do this, I'll say, write the virtual work expression. Okay? All right.